The methods for proving triangles congruent, there are three of them. One is using angle-angle similarity, one is side-angle-side similarity, and one is side-side-side similarity. Angle-angle is probably one of the easiest ones to use because you just need to know two angles of each triangle. You don't have to be comparing sides to see if they're proportional or anything. You just need two sets of congruent angles in your pictures. What they do to disguise this, because they're trying to make these problems a challenge for you, is that they will make the triangles overlapping where they're sharing angles, or they will have vertical angles going on, or they will have parallel lines that lead to angles. So they're not just going to give you information, you're going to have to come up with it based on the picture and the hidden information. So here we're trying to show that these two triangles are similar. They've marked one set of angles as 52. So currently we know that in the top triangle, angle ABE, and you have to use three letters to name that because there's multiple angles at B, is congruent to angle C. There's only one angle at C. Of course, you could use three letters to name it if you'd like. But that was given. Like if I was doing a proof, I'd say that was given. And then these triangles, they overlap. They're sharing the angle at the top. Angle A is congruent to angle A, and it's the only angle up at A, so you can use one letter. And if I was doing a proof, that would be reflexive property. So now that we've got two angles showing as congruent, we can say that they are similar by angle-angle. Similarity would be the reason, and I would name the triangles ABE, similar, triangle ACD, and then that angle-angle would be the reason. For the second one here, we have these arrows on the outer pieces, which mean they're parallel sides. We've also got vertical angles in the middle. So there's ways to get all three of these angles based on these parallel lines here because, alternate interiors, they make that Z shape. We've got a Z like that. We've got another one like that. So I'm able to get these two angles from alternate interior angles. I'm able to get these two from alternate interior angles. And I'm also able to use my vertical angles and get these two congruent to each other. So I could figure out all three. I only need to pick two of those. So it doesn't matter which two I pick. I'm going to go with the alternate interiors just because I can use the same reason for that. So if I said angle S, and it's the only angle there, so I can just say S. S and U make that Z shape, and R and T make that shape. And the reason there is the alternate interior angles theorem that tells me that they're congruent. And so now I can say that triangle SVR is similar to triangle UVT by angle-angle similarity. So pretty short proofs if I had to do proofs there. Here again, same thing happening. Show that the triangles are similar. Okay. In this first triangle, all three angles are marked the same. So that means that they're all the same. But notice they're not marked the same as these angles. So that's they're trying to trick you. If all the angles of a triangle are equal, then you have 180 degrees divided by 3 is 60 degrees each. So by the triangle angle sum theorem, each of these angles is 60. And the same rule tells you that each of these is 60. And since all of their angle pairs are 60, they are similar by angle-angle similarity. And we can name the similarity statement. They said FGH. So they went like that, similar to RQS. That's that similarity statement, is this one. Here, We've got a couple of triangles here. If that's a right angle, then that's a right angle there too. But notice that the ones they marked are not the same angle there. So what we need to do is take your angle sum, 180. If you subtract that 90, that right angle, you get 90 left. And if I do 90 minus 32, I get 58 for the remaining angle that's right here at the top. And now I have two matching angles. So I can name them. I can say that angle CFD is congruent to angle DFE. That's the right angles. And if I was naming that, it'd be like all right angles congruent. And my other one is CDF. That's the one up here at the top that's 58. Is congruent to angle FED, which is here being 58. And so then I could say that, by angle similarity, and the reason for that one's triangle sum theorem. But by angle similarity, my triangles are similar. And the similar is that squiggle. Okay. And then here's just a word problem. A lifeguard is standing beside a lifeguard chair on a beach. The lifeguard's 6 feet 4 inches tall and casts a shadow 48 inches long. The chair casts a shadow that's 6 feet long. How tall is the chair? So as long as your height and your shadow are the same unit of measure, then you can have, it doesn't matter if the person's measurements match the chair's measurements as far as units. But here's feet to feet, that's good. But for this person, it's feet and inches right here and inches here. That's a problem. So since this is feet and inches, I'm going to convert this all to inches for his height. So for the lifeguard, he is 6 feet, so that's 6 times 12, which is 72, and then also another 4 inches. So his height is 76 inches, and his shadow is 48 inches. So now we have matching measurements for the guy, and we have matching measurements for the chair, so it's okay. So we're going to set up our ratios. If I do height to shadow, then I would do height to shadow, and since they are right triangles, and this angle here where the sun is hitting here, it's creating some angles up top that are also equal, so I know that these are similar, and I should be able to set up a ratio for solving. 76 over 48, and height to shadow of the chair, x over 6. Cross multiplying there. 76 times 6. Oops. 76 times 6 is 456. And then 48x, cross multiplying there, so divide by 48. 9.5 is x. Since x is supposed to be feet, that's 9.5 feet. But I want you to be very careful if the choices are listed in terms of like feet and inches. Half of a foot is not 0.5 inches. It's not 5 inches. This would be 9 feet, 6 inches, because a foot is 12 inches and half of a foot would be 6 inches. So you might see choices that are like 9.5 feet or 9 feet 6 inches. If you have 9 feet 5 inches as a choice, that confuses people. So watch out for that. They try to do that to mess with your head.